Today's lesson is how to find the rational zeros of a function. So your essential question is, how can I know what the rational zeros of a function are? So before we get started, I just want to take a second to kind of define this for you. A zero of a function, remember, is when we have a graph, and we've looked at all different kinds of graphs. We looked at graphs that look like this, and they kind of go all over. We've looked at graphs that look something like this, where they go through just like maybe one time and through. So each time that the graph crosses through the x-axis, that is called a zero of the function, because that's the point where it goes through y equals 0 on the graph. So we're finding out where the zeros of a function are without actually having to graph all of it. So the rational zero theorem is this formula here that tells us how to find what the possibilities for zeros of a function are. So to get this, we do what's called the P's and the Q's, which is finding the factor of the constant in the function divided by the factors of the leading coefficient. So for example, if I want to list the possible rational zeros of f, this function, using the rational zero theorem, this is what I would do. I would find all the factors of the constant. So the constant is the number at the end without the variable. So I'm listing all the factors of 12. So these are numbers that I can divide into 12 or that multiply to be 12. So it could be positive or negative. So I could have 1, 2, 3, 4, 6, or 12. So, and any of these could be positive or negative, so I just put one big plus or minus sign there in the very front. You can write it in front of each number, but it's kind of redundant, so I just write it in the very front. Then I have to list all the factors of the leading coefficient, which is the number in the very front. So in this case, it's a 1. So factors of 1 would just be positive or negative 1. And we're supposed to divide those. So if I take 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, you get it. Then my possible zeros would be positive or negative 1, 2, 3, 4, 6, and 12. And it could be positive 1, negative 1, positive 2, negative 2, you get it. So those are the places where it could cross through the x-axis. Now those are just possibilities, so we don't know for sure if that's what they actually are. Those are just possibilities. So go ahead and take a minute if you want to pause the video and try this next example on your own. So I want you to list all the possible rational zeros of this function. So remember, to do that, we're going to find all the factors of 10. Which could be positive or negative, 1, 2, 5, and 10. Then we have to find all the factors of the leading coefficient, which would be 4. So it could be positive or negative, 1, 2, and 4. Now we're supposed to divide all of these numbers. So this one's a little bit different than the last example. Okay, we would have to take 1 over 1, 2 over 1, 5 over 1, and 10 over 1. But then we have to take all those numbers over 2, so it'd be 1 over 2, 2 over 2, 5 over 2, 10 over 2. And then we have to take all those numbers over 4. So this one has a lot of possible rational zeros. So this one, the answer would be positive or negative. We would have 1 over 1, 2 over 1, 5 over 1, and 10 over 1. But then we would have 1 over 2, 2 over 2, but 2 over 2 equals 1, so we don't really need to write that one down. Then we have 5 over 2, and then we have 10 over 2, but 10 divided by 2 is 5, which we already have, so we don't need to write that one down either. So then we go to 4, so we have 1 over 4, 2 over 4, which equals 1/2, so we don't need to write that one down, 5 over 4, and then 10 over 4 equals 5/2, which is already written down. So these would be our possible rational zeros here. Okay. All right, so what do we do with that? Well, let's say we actually want to find out what the real zeros of a function are. So what we have to do is we have to know what our possible answers could be. So if I look at this, what I want to do first is list all the possible rational zeros of this function. So I'm going to find all the factors of 20, which would be positive or negative, 1, 2, 4, 5, 10, and 20, over the leading coefficient, which would be 1, which would be positive or negative 1. Well, if I divide all these by 1, I'm just going to get the same numbers. So my possible rational zeros could be positive or negative, 1, 2, 5, 4, and 10, and 20. So those are it. Well, that's, 1, 2, 3, 4, 5, 6 positive and 6 negative possibilities. So that's 12 possibilities. And there's probably not going to be 12 zeros in this function. It's not going to cross through 12 times. So I need to narrow this down. So to find out if something is a zero, what we can do is test it using synthetic division. So to test it, you just have to pick one at random. I usually always pick positive 1 and negative 1 to begin with, because those ones are usually the ones that work. So let's try 1. So if we try 1, then what we would do is we would bring down the 1, multiply, so we get 1, then add, so we get negative 7, then multiply, so we get negative 7, then add, so we get 4, then multiply, so we get 4, and then add, so we get 24. Now, if it has a remainder of 24, it doesn't divide evenly into the function. So unless we get a remainder of 0, then we have to try something else. So 1 is not a 0 because it didn't work. And in case you're wondering where I got these numbers from in the synthetic division, if we remember to do synthetic division, we use the coefficients of all of these numbers. So I had 1, negative 8, 11, and 20. And so that's where I got those numbers from. So let's try another number. So let's try negative 1 to see if it works. So we bring down the 1, we multiply, we get negative 1, we add, we get negative 9, we multiply, we get positive 9, we add, we get 20, we multiply, we get negative 20, we add, and we get 0. So hooray, it works. So if you get a remainder of 0, then you know that it is a 0 of the function. So what I have to do with that is write down the factors using the 0 that I found. So if negative 1 is my 0, then my factor would be x plus 1. Because if I set x plus 1 equal to 0, I get negative 1 as the answer. So your factor and your 0 are always going to be opposites of each other. Now remember, when we did synthetic division, if I divided by x plus 1, this part would be my answer. So these numbers actually mean something. So this is 20 is the constant. This would be the one with the x, and this would be the one with the x squared. So x squared minus 9x plus 20 is my other factor. Now, I'm not done yet. I'm almost there. I have to see if this is factored completely. So I need to see if I can break this down into any other factors. So are there any factors of 20 that add to be negative 9? So I could do 1 and 20, 2 and 10, 4 and 5. And I would have to make both of them negative for this to work, because they have to both be negative to multiply to be positive 20, and they both have to be negative to add to be negative 9. So that would mean that my factors would be x minus 4 and x minus 5. And I already knew that x plus 1 was one of my factors. Well, if I want to find the zeros, though, these are my factors, but I want the real zeros of the function, then I have to set these equal to 0 to find out where my zeros are. Now, if I'm multiplying three things together and my answer is 0, how is that possible? Well, I would have to multiply 0 by the other numbers. So one of these parts has to equal 0. So if I set each of these equal to 0, that will give me the zeros of my function. So if I set this one equal to 0, I get x equals -1, because I would subtract 1 from both sides. If I add 4 to both sides on this one, I get x equals 4. And if I add 5 to both sides on this one, I get x equals 5. So these are my zeros right here. So what that means is when I draw this graph, I have -1, +4, and +5 as my zeros. So these are the points where it will cross through the x-axis. And if I look back up here, it was a cubic function, and it was a positive leading coefficient. So it's going to go something like this. It has to go down on the left and up on the right. So our graph would look something like that. Now, I know that was a long process, and if there was 12 possibilities and it took me 12 tries to guess and find one of the zeros, that would be horrible. So I'm going to help you guys out and save you some time, and I'm going to let you use a graphing calculator or a picture of a graph to help you find the first zero so that you don't have to test all of them, and then you can just factor and solve and find the others. So, for example, if we wanted to find all the real zeros of this function, the first step is you always list out your possibilities. Okay, so I would have factors of 15, so that would be like positive or negative 1, 3, 5, and 15. And then all the factors of 4, so that would be positive or negative 1, 2, and 4. So if I have my possibilities, they can be positive or negative. I have all these numbers over 1, so 1, 3, 5, 15. Then I have all these numbers over 2, so 1/2, 3/2, 5/2, 15/2. And then all these numbers over 4, so 1/4, 3/4, 5/4, and 15/4. So those are all my possibilities. That's a lot of possibilities. I would not want to have to try to test very many of those. So what we're going to do is we're going to take our graphing calculator, and I have my Wabbit Emu emulator on here. You can download this on your computer as well, so that you have a graphing calculator right nearby. And I've already entered this function into the calculator, but you would go turn it on and go to your y equals screen, if it's going to let me. I don't want to turn on. Hold on a minute. There we go. Okay. So I already entered this into the graphing calculator, but you would go into your y equals screen and you would enter everything in, and then you would graph it. So if I'm looking at the graph, I can see the answers. I have -1, and then I have some other numbers over here that are kind of in between whole numbers, so they're probably going to be some of my fractions. So -1 is the one that I can see that is the whole number. So I'm going to use that one to help me. Instead of testing all of them, I know -1 works for sure. So after I graphed it, I know that -1 is a 0. So I'm going to use synthetic division to get the other factors. So I have to plug in -1, and then I need to go back and look up my function. So I had 4, -12, -1, 15. So 4, -12, -1, and 15. I didn't skip any exponents, so I don't have to plug in any zeros. So I do synthetic division. I bring down the 4, multiply, get -4, add, get -16, multiply, get +16, add, get 15, multiply, get -15, and 0 is my remainder. Woohoo! Now, if I did that and I didn't get 0, I would know something was wrong because my calculator told me that -1 was a 0. So that has to work. So from here, remember, we write down what's left. So I would have, remember, this is the constant, this is the x, this is the x squared. So I would have 4x squared minus 16x plus 15. And then I had x plus 1 as my other factor, because remember, your factor is always opposite of your 0. So if I multiply these two things together, I would get the function that I started with. Now I have to factor this completely. So remember, if there's not a number, or if there's a number in front of the x squared, we have to use the AC method. Remember, this is A, this is B, this is C. So if I take A times C, then I get 60. So I'm trying to find factors of 60 that add to be -16. So I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And so if I did 6 and 10, they would both have to be negative for this to work out. So then I don't just write those as my answers. I have to do the AC method. So I would have 4x squared minus 6x minus 10x plus 15. Then I would factor by grouping. So the greatest common factor here would be 2x. And then I would have left over 2x minus 3. And then I can factor out a -5 here. And then I would have left over 2x minus 3. Now I had to take out a -5 to make these be the same. So sometimes you have to watch that. So then my factors would be 2x minus 5 and 2x minus 3. And then I had x plus 1 at the beginning. Now remember, to get my zeros, I set all of these equal to 0. So I had x plus 1 equals 0, which would make this x equals -1, because I would subtract 1 from both sides. Then I have 2x minus 5 equals 0, so I would have to add 5 to both sides. Oops, I don't know what happened there. And then I would get 2x equals 5, so I'd have to divide by 2. So x equals 5/2. And then I would have 2x minus 3 equals 0. So I would have to add 3 to both sides. So I get 2x equals 3, divide by 2. So x equals 3/2. So there's your 3 answers right there. All right, make sure you guys go back and answer the essential question and write your summary. Thank you.